We've been seeing trees all our life and climbing where possible. I can't imagine seeing fewer trees around where we live, but I can see they're struggling, like spots on horse chestnut trees' leaves.
Trees are essential for the survival of the human race. Not only do they produce oxygen, but they remove carbon dioxide from the air, which reduces global warming. They provide habitats for species of animals, and they can even reduce crime. So it's essential that we help protect these and save the trees, but this is becoming increasingly difficult with the spread of tree disease.
Mathematical models can help us explore the effects of various components on a system. Models are constructed using the language and concepts of mathematics. In studying the spread of tree diseases, we have looked at how modelling can be used to look at parameters such as distance from an infected tree, mechanisms of spread, and immunity. We started out with a very simple model and then modified this to make it more realistic. Where possible, we use real data, such as the information on the spread of a disease called cholera, which affects ash trees. You can see the first documented case is in southeast England, and it spread across the UK over subsequent years. It has now affected almost 2/3 of the UK. We've designed a board game to explore a model of generic tree disease in more depth. By using dice and chance cards, we've tried to reproduce some of the scenarios that occur in the spread of an infection, such as the transfer of spores on infected tools or spread by insects. We've also described some of the activities that demonstrate how maths can be used in examining this in more detail. We've explained how to create a board game and a model that looks at these factors in more depth. As well as this, the physical model has led to a computer program that allows us to change some of the factors and therefore compare the effects of these changes.
We used Python so that the code would be accessible to many people. The program starts with a single infected tree and models the spread of a tree disease across a map. From there, we added additional factors such as human footfall on a path and natural immunity. We hope that other people, such as students or scientists, will develop this program with the use of our activity pack. This will help to create an increasingly realistic model which will help scientists to protect trees from disease.